in chapter 2. We were dealing a lot with data, but one set of data. So we were looking at a normal distribution of heights, just one set of data. Or we did that problem with Tiger Woods where we were looking at how far he hits a drive. Once again, just one set of data looking at how far he hits his driver. Chapter 3 now, we are going to be getting into two sets of data or pairs of data. Okay, so two sets of data or pairs of data we're going to be looking at. So instead of just focusing on one variable, we're now going to be focusing on two variables. Okay, so we're going to be switching it up here. So to start with our activity today, a problem came up in the math department that I need your guys' help in solving. Okay, so if anybody goes by the math office, you see us math teachers hanging out. We often have food in the math department because we like to have food and snack and things of that sort. Well, the other day, I went into the math department and something very, very sad happened. Very sad, very horrible. Our wonderful cookie jar, all the cookies were out. Someone stole all the cookies from the math office cookie jar. Horrible, correct? Horrible, terrible situation. So we, as a stats class, need to be able to solve this mystery. And are we up for that challenge?
Yes.
No. Yes, we're up for that challenge. So, we do have some evidence. We have some evidence. Someone left their handprint on the cookie jar. Not just a fingerprint, but we got even more than that, right? We got a handprint. Very good. So, can we find out who stole the cookies from the math jar using their handprint?
Yeah, okay, that's what you're not serious.
This is very serious. Very serious. Here's our cookie jar. All right, so here's what we're going to do. We do not have time to go around and fingerprint every single person in the math department. We have videotape that it has to be someone from the math department. That were the only people that were going in and out. We don't have time to handprint or fingerprint everyone. But I did contact the HR department. And we do have on file in each HR the heights of every single person in the math department. We have the heights of every person in the math department. So the question is, can we take heights from the math department and somehow figure out whose handprint it is based on heights? What do we think?
Yeah, I mean,
This is crazy.
size of the hand compared to
Janae, what'd you just say? You said something.
universe.
You started saying something. You were right.
The size of the hand in like ratio to your height.
Okay, so basically, the size of your hand, does that have a relationship to your height? Do we think it does?
Yeah.
Are we sure it does?
No. Big people have
You're not
We're not sure. So what we're going to do is we are going to gather some data from you guys. You guys are not the suspects, but we can use your data to help us with the information from the math department. So we think that there might be a relationship between handprints and what? And height. So let's gather that data from you guys. I'm going to pass out tape measures. What are we going to measure? Height and hand size. So here's what we're going to do. I'm going to pass out tape measures. Everyone has a partner. Help each other out. We're going to measure height. So from tip of the toes up to the top of the head. And we're going to measure hand span. So hand span is kind of from one pinky finger to the thumb. Does everyone understand what I mean by hand span here? Don't really crazy stretch it out. Just a relaxed hand. Don't be crazy and stretch it out. Just a relaxed hand. We are going to measure in centimeters, because centimeters will help us get a little bit more precise. All right, so everyone take a tape measure, help you and your partner out. Measure heights, measure hand span, and when you get those answers, we'll put them up on the board. I'll make a table up on the board here.
A, you are 161 tall.
And when you get your information, you can type it up on the screen here. Type it into the computer when you get your information.
That's what? Oh, okay. So that's about 16.
Help each other out.
16 hands.
Who am I taller than? No one. Miss Swanson.
Yeah. Miss Swanson seems about your height.
So hand span from tip of pinky to tip of thumb.
All right.
Tip of pinky to
Sarah?
tip of thumb.
Yeah.
We're doing it in
Centimeters, centimeters, centimeters. Make sure we're doing centimeters. Do you want to pick some?
Okay, so
You can pick some.
from 19.
Yeah.
Okay.
Are these you guys here?
Got it.
9 and 6?
Yeah. Got it,
Yeah, let's
okay.
pick those up. Relationship or a correlation. Yep. Graph it. So your stuff ahead of me. We're going to graph it. So I'm going to give everyone some graph paper. We are going to graph this. We need to figure out our x-axis and our y-axis. Your x-axis is usually what variable? The control variable or the independent variable. Okay, so your x-axis is usually your control variable. Your y-axis is usually your dependent. Or in this case, what we're trying to predict. Okay, so let's think about this. What is known, what is independent, versus what are we trying to predict? What do we know? We know the heights, correct? We know the heights of the different teachers. Like this is our known. So heights is what we're going to put on which axis? Axis, there we go. The x. And then our y-axis is going to be our hand span, because that's what we're trying to predict. We only know one hand span for our teachers. So that's what we're trying to predict. So, using this data, I'll flip the lights in a second so you guys can see. We want to put, we said heights here, and we want to put our hand span over here. Both are in centimeters. Both are in centimeters. You should always make note. So let's flip the lights. Let's take a look. For our x-axis, our heights, what minimum value do we want to start with for our heights? About 160 is our lowest. So we should start maybe with 160. What's our maximum height? 180. 185, we have 185? 188. Is there 188 in there?
Oh wait, no, I'm sorry, looking at this.
Ah, we were looking at the other data, right?
Yeah.
So just on our data, the max we have is 185. So what do you want to go up by to go from 160 to 185? Fives? Now let's go up by twos, because fives is not going to really give us that much, right? So let's go up by twos, so you can take a second. We'll go up.
Are we making it?
Are we going to make a histogram? Good question. Good question. What do we need for histograms? What do we need for a histogram?
1, 2, 3.
Histograms, what does each bar of a histogram represent? Number of observations in that group. Okay? Here, good question, we have our x-axis heights. We're going to have our y-axis hand spans. What am I going to graph here? Am I going to graph a histogram? What will I just be graphing for each of this? Just a marker, just a point, right? just its points. So handspan, what do we want to start our handspan with? We have, what's our lowest handspan? 13 is our lowest. What do we want to start our graph with? Maybe 12 we can start with. And what do we want to go up by?
Ones.
You probably just go up by ones here, because the highest is what, 20? So we can just go up by ones, 13, 14, and so on. You guys can do that, go up by ones. And now we're going to put, for every data point, we're actually going to put a dot. So for the first one, let me finish my grid here. The first person is what? Height of 175, handspan of 22. So now we're just doing some basic like algebra work here. So is everyone okay? We're just going to plot 175 and 22. And just put a dot there. Everyone okay with that? What we're creating is not a histogram. Histogram is for one data set. What we're making is what we call a scatter plot. I know it's small. This is a program that I'll pull up every once in a while. It's called Minitab. And there's not really a way to expand it. So yeah, so feel free, take a picture, zoom in on it if it's easier to see. So what did we say was our y variable? What was on our y-axis? Handspan, so I'm just going to click that in there for the y. And what did we say was our x variable? Height, so I'm going to click that in there for height. And it's calculating. And here we get something that looks like our scatter plot. Yours might be a little bit different. They did go up by 5s here, and they went up by 2s here, but it should generally look the same. The scale might be a little bit different, but generally look the same. So what do we think? Relationship? No relationship? What do we think? Is there any overall pattern with this data that, at all that might help us with our predictions? Yeah?
I feel like besides like the couple points,
Okay.
overall you can kind of see like a trend of on the lower side of heights, like shorter people have like shorter handspans. I mean smaller handspans. And then as it increases, so does the handspan.
Okay, so that is one observation. Overall, we do have some deviation from this, but overall, those that had shorter heights had smaller handspans. Those that had larger heights had larger handspans. So which direction is that going in then? A positive direction. Remember from algebra, this would be then a positive relationship. So that is one way to describe data. And this is something that's going to be very important coming up in the next couple days. What kind of relationship is it? Positive or negative? Does everyone see how this is more of a positive relationship? Other information we can gather from it. Is it a fairly strong positive relationship?
No.
What would a very, very, very strong positive relationship look like? If I was going to graph a very strong positive relationship, what would that visually look like with our dots? What would that visually look like with our dots? You know what you say?
Linear.
Linear. So what does that mean? Linear. If it was a strong positive relationship, the dots would be more linear. Do we have a very linear plot here? No. So what would we say? Is this strong then? No, we could say it's more of a weak positive relationship. There still looks to be a relationship, but it's more of a weak positive relationship.
Couldn't you look at like the teacher's height compared to our heights and our handspans? So like
Okay.
if one of the teachers has like a similar close to height as us, we can kind of.
You're on the right track. So we can look at the teacher's heights relative to our heights and see if someone's similar. There's another piece of information we need then. There's one more key information we need. The relationship. So I have the heights, but we're missing a key piece of evidence. Hints, hints, hints. What else do we need? The hand span. So if we need to know the hand span. So who wants to measure our hand span for us? A volunteer who wants to measure our hand span? A height of 168. Is it likely that her hand span is 15?
Yeah.
Well, let's see. So if we have 168, so we know the height 168. Is it likely, there's some other information I would want on this graph to kind of help organize things a little bit for us? A line. If I put a line on this data, what kind of line do we want to put on this data?
Trend line?
A trend line. We're going to call that a regression line. So a regression line or a trend line, exactly what Hamza said, can help us see things a little bit better. So we're going to call this a regression line. So same thing, our y variable was hand span, our x variable was height. It's going to calculate for us. Okay, so now, what is this linear line telling us? What is this representing? The slope. And we agree, what kind of slope is it? Positive, because that's what the trend was that we saw, right? We saw low height, small hand span, large height, large hand span. So this regression line is giving us, there's a word I'm looking for, I don't know if you guys talked about this in algebra or not. Line of best fit. Have we heard that before? Line of best fit? So this line is helping us kind of see what matches the data to the best. So once again, going off of our heights, so back to Mrs. Abed, who was 168, what would be her predicted hand span? How can I find what her predicted hand span would be? Where am I going to go? So if I'm at 168 here, what should I look for? Look up, and then where am I going to go? To the line, and then where am I going to go? To the left. Does everyone see how we can kind of use this to make some kind of prediction now? So at 168, if I go up and I go over, that would be a height of approximately 17. Was that, or excuse me, a hand span of 17. Is she a good suspect for this crime? Probably not. Maybe, but probably not. Mr. Alexander, 184. Emma, what did you say? Definitely not, right? So Mr. Alexander's 184. His hand span's going to be what? Approximately about 20 there. So Mrs. Abed, probably not. Mr. Alexander, is he a good suspect? Mr. Alexander, well, if you know Mr. Alexander, maybe he would be a good suspect, but in this situation, Mr. Alexander is over here, right? So let's look through the data. Let's see. Who do you think would be a best suspect that might have stolen the cookies from the math office? Ms. Groff we're looking at? All right, so Mrs. Groff is 165. Close to that 15, right? So we think Groff's a suspect. Vanderjack's a suspect. So Groff we think is a suspect. Vanderjack we think is a suspect. So now we don't know 100% who it is, but do we have an educated guess on who it might be? Yes. What we're going to get into eventually, like I said, this was meant for a preview. There's something that's going to be called confidence intervals. How confident are we that it's this person or this person? So what is our confidence level on it? Are we confident that it's not Mr. Alexander? Yes, we're pretty confident with that. But are we confident that it is Mrs. Groff? Okay, now, it could be Mrs. Groff, it could be somewhere else in there as well. Okay? So we have to kind of ask ourselves those questions of confidence. Who is it likely to be, who is it not likely to be, and a percent on how confident or not confident are we. Questions with this? We want to know who stole the cookies.
Miss Groff.
Mrs. Groff's a good guess, but it's not. Wasn't Mrs. Groff. It was Mrs. Swanson. And let's look at that. Mrs. Swanson. Mrs. Swanson had a height of what? 160 was Mrs. Swanson? Who's the closest to that 15? Ms. Swanson. 15 was here, right? Isn't that closest to the end of the lowest? So actually, even though it wasn't a perfect linear line, if you really want to take into consideration the best guess, Mrs. Swanson would probably be the best guess because she was 160 centimeters, which is pretty much the closest to that 15 hand span. So even though it wasn't a perfect relationship, it really tells us a lot.